button on the side, and we are going to draw some graphs today. Okay, so exponential functions. I like exponential functions. There's really nothing too wild or crazy about it. We're going to do the graphs. Now, there are some word problems towards the end, of course, as we're used to always seeing word problems. A lot of problems in this chapter, or throughout the chapter, that are going to talk about money, investing. You invest money in a bank, they pay you a percentage to have it in there, how to calculate your interest. So we're going to start taking a look at some of those. All right, so anything and everything to do with exponents is what we have happening here in this section. So just testing some of our basic exponent knowledge. What's 3 to the 4th power without a calculator?
81.
3 times 3 times 3 times 3. 81. Riley. What was... Riley, did you have a question or an answer?
No, I was saying.
You had an answer. I'm just glad nobody in here said 12. Every once in a blue moon somebody tells me that. I'm like, oh boy. Okay, let's test our exponent properties. X squared times x to the 5th. X to the 7th. You add them. Now, there's a good review of, if you remember that first chapter we did, that 12-section monster first chapter was these exponent properties. All right, you cannot have a negative exponent, so you would put this down in the denominator. So your best final answer is 1 over x to the 5th, 3 and 2, 5. Got it? Okay, D, same spiel. You can't have a negative exponent, so of course the denominator moves to the numerator. There's nothing offensive about 5, just leave 5 as it is. And then the x to the 6. I'm not putting over 1. So you will see some negative exponents today. Obviously on the graphs, we're going to do the graphs. I'm going to do some of the negative exponents in my head. I'm going to do them by hand, old school, hardcore, because you never know when I might throw you a no graphing calculator quiz. You know I love those. The looks on your faces, I love it. Okay, so let's get into what is an exponential function. Definitely need your calculators for these bottom ones. Exponential function f with a base a is denoted by f of x, a raised to the x power. So notice x represents the exponent. Now, you're going to need your calculator clearly to do some of these. I mean, remember, 5 is x. So you're figuring out what is 3 to the 5th power. We're going to need a calculator for that. You're going to have to figure out 3 to the negative 2/3 power. You're going to have to figure out 3 to the pi power. Seems weird, but we can do it on the calculator. And of course, we're going to have to do 3 to the square root of 2. All right, I have every confidence you can type the first one in. What's 3 to the 5th? Punch that one in. 243. Now, don't let this B scare you. I'm just going to pull up my calculator here. I'm going to type it in exactly as it appears. I'm going to do 3 raised to the negative 2 divided by 3. And it doesn't say what to round to. Let's just go 3 decimal places. I'm going to go 0.481 on that. Same thing, 3 to the pi. I'm just going to literally type that into my calculator. I'm going to use the pi function though, because I want it as exact as possible. So I don't want to just round off and use 3.14. So let's put 31.544. Let's just, I guess, round everything to the 3 decimals. Why not? All right, final answer. What do you got for 3 to the square root of 2 power? I'm just going to round it. So any questions on typing those in the calculator? Clearly, I would not expect you to do any of these problems up here by hand. Okay, that would definitely be on a calculator part. So first big topic we want to talk about is doing the graphs, graphing exponential functions. Now, I'm going to do some of it by hand. I'm going to be doing some exponents in my head. Clearly, some of these crazy large numbers, 3 to the 5th, boy, that grew fast. I'm going to have to be conscientious of what I'm putting in these when I make my t-charts. Now, you can see here, just gave you a couple pictures of what they look like, these lovely curves here. Domain. We're going to talk a lot about domains on exponential graphs and eventually logarithmic graphs. So domain on an exponential graph is super easy. There's no restriction. I can put any number I want, as you just saw in that last problem, for an exponent. I had a fraction, I had a negative, I had pi, I had, square root of 2. You can use anything you want for an exponent. So the domain on these are always all real numbers. You can see on the graph, they're not super drawn there, right? But these all have a horizontal asymptote. The line you get close to, you don't cross or touch. Draw it in there in red. Of course, it's the x-axis on these. Now, is it always y equals 0? No. On the parent functions, it is, obviously. But they could have some shifting, which we'll see today. Some vertical shifts up and down, left and right, that sort of thing. Same on your y-intercept. On your parent functions here, our basic functions, you can see it hits the y-axis there at 0, 1. And again, that might change if we have a vertical shift up or down. That's going to affect that point, which we will see coming at you in a minute. Okay. All right, let's draw some graphs. So I'm going to do it by hand. Yes, that's how I roll. Can you put that in your calculator? Sure, sure. It says to graph it by hand, though, so this would be, want to do it by hand. All I'm going to do, there's no magic here. There's no, hey, you need to have 5 numbers in your t-chart or whatever. Because sometimes, as you saw, like 3 to the 5th was 243. I can't fit that on the graph grid. These grow very large, very quick, very fast. So I'm going to pick small numbers. I'm going to start with 0, something easy. 3 to the 0, anything to the 0. Got it. I'm going to put 1 in for x. 3 to the 1st. Got it. I'm going to go to 3 squared, 9. I can still fit that on my graph grid. I'm going to probably stop for positive, because if I go to 3 cubed, what's 3 cubed? 27. I have that. Okay. Let's do a negative. So here's where we have to know our negative exponents. 3 to the negative first is what very lovely fraction? 1/3, because that would move into the denominator, so 1/3. Or, hopefully we see a pattern here. Now, I'm going to estimate that. -1/3, okay. Let's try -2. What lovely fraction is 3 to the negative second? 1/9, yeah. So here's the hardcore exponent property, move it in the denominator. Or like I said, do you see a pattern, a relationship? +1 was 3, -1 was 1/3. +2, 9, -2 was 1/9. Okay, clearly, that's whatever. So I'm going to draw close to the x-axis. I'm not going to cross or touch, because technically our x-axis is my horizontal asymptote. And I've got all sorts of good stuff to answer over here now. So, domain, I don't even have to think about it. Exponential functions, I can put anything I want in there. We drew the horizontal asymptote, y equals 0. Plus, I knew it was going to be 0 because there was no transformation. There was no vertical shift up or down. It wasn't like a +3 at the back or something. X-intercept, well, it doesn't hit the x-axis, so big fat none. Y-intercept, 0, 1. All right, we've done increasing or decreasing. Look at the graph left to right. Decide, is it getting bigger or smaller? So as you look at it left to right, increasing or decreasing? Increasing. And I'm just going to abbreviate, you can too. And again, you could type that all into your graphing calculator, but we should know how to do these by hand. You know I love a no calculator one. Okay, so this time I did the reciprocal, I flipped it. Notice instead of 3 to the x, I flipped it on purpose to 1/3 to the x. So let's see how that affects the graph. Same thing, I'm going to use a t-chart. I'm going to pick some nice easy numbers, see what I can fit on there. Anything to the 0 power 1. Actually, I don't have very tall shoes on. I'm just going to lower this down a little bit here. Okay, I'm going to put 1 in. 1/3 to the first power. I really love graphing fractions, as you know. Now, if I put 2 in, 1/3 squared. 1/3 times 1/3, gross. So I'm probably done with my positive numbers, because if I go to 3, I'm going to have 1/3 cubed. 1/3 times 1/3 times 127. I can't graph that. Okay, let's go to a negative. Now, don't overthink it. Of course, it's a pattern. If 1 is 1/3, what does -1 give you? 3. 3/1. What will -2 give you? 9. 9/1. Good. Okay. So I'm going to draw my curve. Pretend I hit those points close to my x-axis, which is my horizontal asymptote. Okay. And then we can answer all the good stuff here. Domain, again, you can put anything you want in for x. Asymptote still at 0. We didn't have a plus or minus anything in the back, no vertical shift. X-intercept, not hitting it. Y-intercept, 0, 1. Increasing or decreasing? Decreasing. As you follow it left to right, it's getting smaller. Now, before we do the next one, I could have told you without even drawing the graphs or anything, just patterns, math, just to help the cause. This graph I knew was going to be increase. This one I knew was going to switch to decrease. How do you know without even having to draw the graph from the equation?
Because you designed the lesson plan.
I was ready for like a real intuitive answer there. Look at your values. Look at what you're raising to the x. Here you have 1/3. Here you had 3. So I can tell you just from the fact the 3 versus the 1/3. Anytime you're over 1, it's going to be increasing. I don't just want to say a fraction, okay? Because what if you have 4/3? 4/3 is over 1. That would be increasing. If you're between 0 and 1, I know just from looking at it, it's going to shift into a decrease. So you can tell just from the equation too, or you should be able to tell whether it's going to increase or decrease. Okay, done with my spiel on that. Just figured, I should tell you that. All right, let's write some equations now. Find the exponential function f of x equals a to the x whose graph is given. Okay, so I'm going to use, of course, 2 key pieces of information. They want it in this style, so I'm just going to jot that down so it's here in front of us. And they want me clearly to use the point 225. Okay. Now, I know you know ordered pairs x, y. So I'm really just plugging those 2 numbers into this equation over here. So x I'm going to put as a 2, so a squared. And 25 is my y, or my f of x if you're in function notation. Okay, you can solve for a. What's a? Technically, it should be plus or minus 5. You know I got to be technical, right? But I'm clearly not going to pick one of those. This is why I went on that whole tangent on the last problem about, there's always a method to the madness, increasing versus decreasing. This one's increasing, so I know a should be over 1. So I'm going to use 5, positive 5. That's kind of a bad circle job there, positive 5. So my final answer, I'm going to put f of x equals 5. 5 is my a to the x. So plus or minus, I just rejected the negative because we had an increasing function. Okay, same thing. I'm going to just jot down my formula. Clearly they want me to use the point 3, 1/8. So I know you know 3 is x, 1/8 is y. So let's plug those in and figure out what a is. So 3 in for x, 1/8 for y. So we have to figure out what fraction, let's get real about it, it's going to be a fraction. What fraction cubed is 1/8? You got to have a little bit of number sense here. If the fraction's weirding you out, just think about 8. What number cubed is 8? 2. Do you agree that 1/2 cubed is 1/8? Yeah, so my a, of course, is that. Or if you really want to get technical, let me just jot this down quick. If you really want to get it technical, but we should be intuitive thinkers in here. To get rid of cubing, of course, you could just go old school and cube root it. Cube root of 1 is 1, cube root of 8 is 2. But, little number sense. Okay, final answer. F of x equals, our a is 1/2, and we're going to raise that to the x power. Now, I'm going to put 1/2 in parentheses, because I want that entire fraction going to the x power. If you don't have parentheses on it, it looks like you're just putting the 1 to the x power. Details matter, right? Details matter. Any questions on writing the equations? Not that that's tricky, but that's probably something new for you. All right, transformations, nothing wild here. This is almost where I wish we had like digital notes in a way, and you could just take that given graph over there and shift it and not have to redraw the whole thing every time. But, it is what it is. Okay, so use the graph to sketch the graph of each function, and then it also wants us to state domain, range, and horizontal asymptote. Let's do all of that at the end. So clearly, we're using that 2 to the x over there. I see this is an addition to that equation. What does adding 1 do? Up 1. So, I'm just going to make myself a little note here. So all I'm going to do is try to take this red graph. I'm going to steal a couple points on it here. It looks like 0, 1, 1, 2, yeah, 2, 4 would be on there. I'm just going to take those 3 points. I'm not going to get crazy here. And I'm just going to shift them all up 1. So 0, 1, I'm moving up to 0, 2. I'm moving 1, 2 to 1, 3. I'm moving 2, 2, 3, 4, 2, 4 to 2, 5. And I'm just going to sketch it. That's a pretty rough sketch, but we're going to go with it. Now, it also wants you to state domain. Well, that's always the same. I don't even have to really think about that a whole lot. It also wants you to do, this time, they've added range and horizontal asymptote. Well, I'm going to do the range at the end. Let's do asymptote. So I knew the horizontal asymptote was going to be at 1 because we have that shift up. So if I could draw up a little better, we wouldn't be touching at 1. Which I went ahead and kind of did a little out of order because your horizontal asymptote obviously also affects your range. Range, remember, y, up and down, lowest to highest. We are above 1 for my range. So, I mean, a couple ways you could say, write it. We could do all real numbers, y is greater than 1. You could do your interval notation. It doesn't matter to me. Notice though, this is tiny detail but important detail, I do not have the equal to on here. You cannot actually equal out to a 1. You have to be greater than it. You have to be above it. All right, what's the negative in front here? What's the transformation on that? This little negative in the front. Anytime we have a negative, it's a reflection. Now let's get specific. I need to know which axis does it reflect over, x or y? X, good. If you're like, oh gosh, I don't remember. If you have the negative in front applied to the entire function, it's x. If the negative would be on the exponent up there, then it would be y. So I need this red graph to reflect over x. So it needs to flip down, basically. So I'm just going to do that with the points here. You're 0, 1, so it's going to be 0, negative 1. I'm going to plot it over there nicer, of course. Here you're at 1, 2, so when I reflect it, 1, negative 2. And this guy that was at 2, 4 is going to be at 2, negative 4. So I'm just going to draw it through there a little nicer over on this graph, of course. Of course, it wants domain and range. Domain. Domain never changes on these exponentials. You can use anything. I'm going to go out of order again because that's how I roll. Horizontal asymptote, no vertical transformation, so still at 0. And our range, okay, this time we are underneath 0. So you could say our real numbers, y is less than 0. Or I'm going to go interval notation. I'm from negative infinity up to 0. Parentheses, not including 0. Or like I said, I'll write both for you. I'll take either version. It doesn't matter to me how you want to do it. Now, and again, could you, if you're not sure which axis it reflected over, could have you punched that in your calculator and looked at it? You could, but we should know, Okay, x minus 1. This minus 1 with x is a horizontal shift. Does it move it left or right? Right, good, right 1. So, of course, yours are all on one lovely piece of paper there. I'm going to click it back. I'm going to take my original red dots here, and I'm going to move them each right 1. So 0, 1, I'm going to move it right 1. So 1, 1. And then my other dot, my other point here, my 1, 2, I'm going to move it over to 2, 2. So just move them all right 1. And then, of course, we had, what was it, 2, 4? 2, 4. I'm going to make that 3, 4. And draw. Not the best drawing, but we're going to go with it. Oh, I feel like a broken record. Domain, of course, still all real numbers. You can use anything you want for an exponent. Now, our horizontal asymptote, no vertical shift, no up or down, so still there at 0, of course. And our range, just looking at the graph, lowest to highest, we're above 0. So I'm just going to go interval 0 to infinity. Any questions on those guys? All right, everybody's still awake? I hope. Now, this is, and I'm going to show you this on your calculator here in a second. This is what we call the Euler number E, and you're going to be like, what in the world is this craziness about, okay? And you will see when we get into logarithms. We're just exposing you to it now. If you look on your calculator on the left side, there's this button here that says LN. We're going to be using that eventually. That stands, it's a little dyslexic, it stands for natural logarithm. Okay, and then of course as you look above it, it says e to the x. That is this Euler number E. Don't get it confused with this letter E above division. If you look at, there's an alpha keyboard on here and there's different letters. You are using the E above LN. Make sure you find that first on your calculator. Now, what exactly is this? Do you have to memorize all this? No, but I just want you to know where this number comes from. So if you look at this expression, and you just keep putting larger numbers in for the end. So they did 1, 5, so on and so forth. You can see these, especially down here towards the end, they're just really 2.718. That's how I remember it, 2.718, almost about 2.718. This is, of course, what we talk about when you get into calculus, a limit. You're approaching 2.718. That's what we call a limit. For our sake, for today, you just need to know where to find it on your calculator. We are going to use it when we start solving equations that have natural logs in them. It cancels out a natural log. All right, that's a spiel for a different time. So natural exponential function, you are going to have this E, Euler number E, named after a famous mathematician with the last name Euler, where that comes from. Euler number E is your base. Just for the record. Okay, so we're just typing in our calculators, just practicing, getting good with the calculator. Punch those in. I'm going to have you try it first. So let me give you a couple seconds. Try those. So again, just to do the first one, make sure you're using the E on the left side, so you have to hit second LN to access it, and then you just have to type in the exponent. So I'm going to round that. I love it when it says 5 decimal places. I'm like, geez, who typed this? That's what you should get for the first one. All right, type in the second one. So again, don't let the 2 scare you. Just hit the 2 first, your second LN button, and then your negative. That's a teeny tiny negative there, 0.53. So let's go 1.17721 for that. All right, and what do you have for your final answer? 121 point what? Perfect. So any questions typing those in? So at this point, you're like, what is this weird E thing? This, I don't get it. It doesn't mean anything to us. It will when we start solving logarithmic equations that have natural logs in it. Just there's my spiel. We're just getting you used to it and where it is on the calculator. Now, graphs. These are going to be like the same curves I was hand drawing earlier, but clearly I can't do E in my head, so we're definitely using our calculator on this. Notice it doesn't say sketch it by hand, okay? So let's use our calculator. So pull it up, y equals. Let me clear out some stuff in here from earlier. So hit your second LN button, and then negative x. Hit graph, of course. And you can see very similar curves. Now I'm going to try to stay off my rant. Well, no, I'm going to be on it. How much I hate Texas Instruments. Should that curve be touching the x-axis? No. Doesn't it look like it does on the calculator? Okay, makes me so angry. And when you go to get some points, hang on a sec, Elliot. When you get some points, I mean, those are pretty brutal. If you ask me, when you look at the T-chart, I'm like, is there a single, oh, what? 1, that's well. Is there a single nice number in here? Sure isn't. And let's just remind ourselves, this E down here, let's talk about that. E is what I call a calculator answer. The E means scientific notation. That is 9.1 times 10 to the negative fourth, or point. 0, 0, 0, I lost track, 3 zeros, 9, 1. So it puts it in scientific notation because of all the decimals. Elliot.
For some reason when I try typing the equation into my calculator and graphing it, it gives me an error sign.
Let me take a look at it because there might be something else turned on in your calculator. So try to get some points, decent points, estimate them off your T-chart and plot it. Power of technology, you're going to hate me, I'm just going to cheat. There's my graph. It's one of my best drawn graphs, kids. No. Well, you guys sketch that quick. I'm going to see if I can look at Elliot's. I'm guessing you might have, I don't know, use subtraction instead of the negative key. Why it's so picky it is, but it is. Yep, there we go. So I make sure I use the negative key. All right, then we got to do domain. Okay, domain, let's write all real numbers for the 50th time today. Range, we're above 0. And our horizontal asymptote, of course, is still at 0, even though that picture looks like it hits 0, and it really makes me angry. But anywho, okay, done with that spiel. Let's type in the next one here. So 3e, second ln, 0.5x. I really should get a job at Texas Instruments, I tell you. I'd regret that. All right, so shouldn't be hitting the x-axis. Yeah, these are all pretty bad. I'll actually draw this one. I feel bad for you. So I'm going to do 0, 3. What else we have in here? I'm going to estimate 1, 4.9, give or take, right? Let's do negative 1, 1.8. That looks good, because they're all pretty bad. I'm clearly not doing anything too large there, and I'm just going to sketch the graph, but I'm going to actually make mine look how it should and not hit the x-axis. Okay, domain the same. Bless you. Of course, are all the same. It's all the same stuff. No vertical shift, so our asymptote's still at 0, and we are above 0 for the range. We can go in interval notation just to mix it up for us. Okay. So any questions on the graphs? All right, last thing I have for you. We're going to talk, remember at the beginning, I said we're going to talk about investing money, compound interest. We're going to talk about all this good stuff. Now, this formula I'm guessing you probably have not seen before. It looks kind of crazy, but it really isn't. It really isn't. I just need to explain to you what some of these letters mean. So A, of course, that's what I always think of, your amount in the account. How much money you end up in your savings account, investing account, whatever you're going to have. P is the principal. Now, you might be like Principal Doherty? No. Principal, when we talk money, is how much you invest in your account to start with. So I'm going to put starting investment. So if you open a savings account with $500, the principal is $500, what you open your account with. All right, R is rate, clearly. Nobody misses that. R is rate. T is time, number of years. Okay, and then N is the number of times, this is a key one, it's compounded per year. So if I say daily, how many days are in a year? So N would be 365. If I say monthly, how many months in a year? 12. If I say, and God help me, I sure kids got this wrong on one of their tests. If I say weekly, 52. There's 52 weeks in a year, not 48 or 54 or any other random weird numbers I've seen for that. Okay, good. We're clear on all of that stuff. All right, so it's really just plugging numbers into the formula. Now, you're going to see your little note here that's on the bottom of this is on the side of yours. This is going to come into play on part B. So I just want to point out one thing on this little note here that's key for us with this formula. It says, if an investment earns compound interest because part B is going to talk about the annual percentage yield, percentage yield, is the simple interest rate, percent rate, that at the same time at the end of 1 year. So when it says annual in there, they're assuming you're going to use T as 1. Annual 1 year. Now, do I think you could probably figure that out? Sure, but I just wanted to make sure we were crystal clear on that because we need that for part B. Okay, here we go. Sum of $1,000 invested in an account. Interest is 12%. Find the amounts after 3 years if it's invested annual, semi-annual, quarterly, oh gosh, monthly, and daily. Oh, okay. All right, let's start with annually. So, annually, of course, N is 1. Now, your $1,000 is your principal, so I'm going to put that in for the P. So I'm just thinking about what my formula is. So I'm on the, really the 1 plus. I'm doing the R over N. Now, on your calculators, though, our R is 12%. I don't have a percent key, so I'm going to put that in as a decimal. And annually. And then we are raised your exponent. N is in the exponent, and then T your overall time. So N, still 1, and we are doing this for 3 total years. That's a 1 times 3 there. From here, this will give you your amount in the account. My A. I'm literally typing that into my calculator. I'm not doing anything fancy. I'm just punching it. I don't know. Well, I don't know. Let's be honest. Am I going to put over 1 and probably not? So 1,000. 1 plus 0.12. Since it's over 1, I'm not putting over 1. That just seems waste of keystrokes. 1 times 3, I can just do that in my head, 3. Now, we're talking money here, so I'm going to round that to 2 decimal places so I have dollars and cents. So I'm going to put 1404.93. Okay. So, I mean, not too shabby. After 3 years, we started with 1,000. This is what you would have after 3 years. So you made in profit almost $405. I can live with that. Now, this really gets repetitive. It's just changing the numbers. Because now they want you to do it semi-annually. So the only thing I'm going to do is change the N's to 2. Then I'm going to change the N to 4, 12, 365. And I'm just going to keep typing it in. Okay, so then we're going to do 1,000. Semi-annual 2, we said. 2 times 3 now. So let me give you a second. Write that down. We'll type that in a minute. And then I'm going to do quarterly. Or 4 quarters in the year. 4 times 3. Monthly, I'm going to change it to 12. And I'm running out of room. Bless you. What am I on monthly? 12. And then, of course, daily, you're going to switch to 365, which I'm really out of room. So I'm going over 365. 365 times 3. Woo. Okay. Now, do I think we need to type them all in? Probably not. Elliot, let me type one of these in, then I'm going to answer your question here. I'm going to do the blue one. We don't have to get crazy and do them all. So I'm just literally as it appears, 1,000, parentheses, 1 plus 0.12. Now, it is over 2. Clearly, I'm putting the over 2 in. And I can do a little mental math there. I had 2 times 3. I'm going to make it look. Okay, so $1,418.52. Let's go with $14.18.52. I already forgot. Was it 52? Yeah, 52. Got it. Okay, so keep typing those in. Get the other ones while I answer Elliot's question. What do you got for me, Elliot?
I can't read the variables in the exponent up here.
Oh, it's NT. A tiny NT. Okay, so type those in. Get the black one for me. We don't have to do them all necessarily. I trust your calculator skills. Get the black answer. clearly I'm pretty sure it's 14,000 something. I see a pattern here, right? All right, do you have the black answer, 14,000?
No.
1,425. What do you got for change?
76 cents.
Agree. Okay, and not to bore you, I know you can punch these in. I'm just going to give you the green answer on this guy. Or maybe you've typed them all in. Have you typed them all in?
Avery's getting one.
Avery's going for it. I like it. Let's see what she gets for this one. No pressure. No pressure, Avery. I have faith in you. Especially, I wrote this one so quick I can't read my messy writing.
Wait, what?
The monthly I got 14, 30, and 77 cents.
Same here.
Oh my gosh.
Good work, Avery. Good work. And then the last one I'm just going to give it to you is $14.33
What is 365?
and 24 cents. Yeah. Okay, so question for you. What's the pattern here? It goes up. So thank you for that. So is it better to have your interest compounded more frequently or less frequently? More frequently, because you want to keep adding to your money. Okay, there's my spiel about money. All right, let's do this last one. Example 8. Find the annual, okay, so this is my spiel here. Annual percentage yield, annual time 1. Catch that, it doesn't clearly say it, but annual is your tip off here. Okay, find the annual percentage yield for an investment that earns interest at a rate of 6%, compounded daily. How many days in a year? Okay. So I'm thinking about the formula, and I'm like, well, this is kind of riveting. Clearly we know what R is. I know what N is. I've got the T. Do you know what your initial investment is?
No.
Okay. But I think we can still make it work. So my amount to my account, the principal, which I have no clue right now, whatever. Okay, my rate, of course, 6%. N 365. And then remember your exponent is N times T. Okay, all right. Well, I would at least get my calculator out and I can punch all of this stuff in, and let's see what that gives me. So punch that in. It's going to be a gross decimal. See what you get. Calculator keys. Should I type this one in?
1.6.
Yeah.
1.0618.
Yeah. You got it.
1.
So I heard 1.0683.
No. 183.
Oh.
I'm sorry.
No, I agree. So I'm looking at this and I'm like, well, okay, I can't tell you what the overall amount in the account is because I don't know the principal. That's a problem. But that's not asking me for it. It says, no, we're not done. Find the annual percentage yield. Question for you.
Oh, it was on the.
How much over 1 are you? Is this a decimal?
1.606.
Owen, say that again. Say it louder.
6%.
6%. Or if you want to get technical, 6.183%. How did I come up with that?
It's over 1.
How much you're over 1? 1 is 100%. How much over 100% are we? We are this amount, which I'm going to put it down as a percent. I don't care what you round to. It doesn't say. So that is my annual percentage yield in 1 year. That would be the percentage yield.
Oh my goodness.
All right, so who cares? We don't need the principal.